Okay, this is 2025 trial paper 1. Okay, it says question 1.1, given f of x is equal to x squared minus 3 into 3x minus 1 into x plus 2, solve f of x is equal to 0 if x is an integer. So first let's solve all of them. We have x squared is equal to 3, or 3x is equal to 1, or x is equal to negative 2. This is x is equal to 1 over 3, right? We're going to square root here, square root, don't forget your plus minus. X is equal to plus minus the root of 3. Right, then for it to be an integer, for x to be an integer, we need to cancel out this one, and we need to cancel out that one. This is the solution. Remember, integers are full numbers, no decimals, no fractions, just full positive and negative numbers. Right, for x to be a rational number is anything that you can write as a fraction. Anything you can write as a fraction, and also they are surds that produce perfect whole number answers. For example, what is the square root of 16? You can immediately tell me it's 4, but if I ask you what's the square root of 15, you can't tell me the answer. That's irrational. So rational is surds that produce perfect whole number answers, like the root of 16. Irrational is surds that don't produce perfect whole number answers, like the root of 15. So this is irrational, this is rational, this is rational, because a rational number is anything you can write as a fraction. This was rational. This you can write as minus 2 over 1. That's also rational. So your answer here is x is equal to 1 over 3, or x is equal to negative 2. Solve for x if x is a real number. Real is everything in math except non-real. So what is non-real number? What is a non-real number? A non-real number is the even root of a negative number. So if you have an even root, square root, fourth root, sixth root, 100th root, and under the root is a negative, that makes it non-real. So everything else is real, which means we don't have the even root of a negative number here from our solutions. So none of those solutions are non-real, so they're all real. Again, even root of a negative number, meaning the negative must be under the root for it to be non-real. Under the root for it to be non-real, right? So all my solutions here are real. There we go. Solve for x. Correct 2 decimal places means that we need to use the quadratic formula. That's x is equal to minus b plus minus the root of b squared minus 4ac all over 2a. This gives me minus into minus 9 plus minus the root of minus 9 all squared minus 4 into minus 15 into 4 all over 2a. That's 2 into, minus 15. So x is equal to, this question said round up to 2 decimal places. We had negative 0,9 as one of the answers. So to 2 decimal places, that would be negative 0,90. And the other one is x is equal to 0,30. Those are my 2 solutions. Remember your marker location here, there's 3. If you don't have this, in order to obtain full marks, if you don't have this, they're not going to give you your full 3 marks. One of the marks is the substitution into the formula. So they're very tricky about that nowadays. So make sure that you show that step, right? Okay, next we have a 3x minus 2 all squared. Okay, it's an inequality. You're going to get rid of the bracket first. First times first times last times 2, last times last. That's 9x squared. First times last times 2 gives me a minus 12x plus 4. Bring that 3x over, it becomes minus 3x greater than or equal to 0. That gives me a 9x squared minus 15x plus 4. Greater than or equal to 0. When we factorize this, 9x is 3x and 3x, and 4 and 1. Right, both are negative. That's greater than or equal to 0. There's two ways that you can do this. I'm going to use the parabola way for now. So your critical values here is going to be 4 over 3 and 1 over 3. So we're going to 4 over 3 and 1 over 3. The graph is a smile. And we want to know where it's above. So it's above at two separate areas, there and there. So less than 1 over 3 and greater than 4. Less than 1 over 3 and greater than 4 is where the solution lies. Right? So we're going to say it's where x is less than and equal to 1 over 3, or where x is greater than and equal to 4 over 3. Okay. This one is K method. Whenever you see a prime number or any number raised to an x, most of the time you use the K method. But the K method you can't use unless you have your 5 to the x's alone. So currently this is a combination of two different bases. So what we're going to do is we're going to have 5 to the x is equal to 5, distribute in. Right, that gives me 20 plus 5 times 5 to the 2 minus x. So when we distribute this in, this is 5 times 4, which gives you 20, and this is 5 times 5 to the power 2 minus x. Right. Sorry. Okay. So before I can make anything x, I need to sort this situation out. So I first need to split that base apart. So this is going to give me 5 to the x is equal to 20 plus 5 times 5 to the 2 times 5 to the minus x. Split that apart. Then what you're going to do is you need to make this negative exponent positive by taking it under. So this is going to be 5 to the x is equal to 20 plus 5 times 5 squared. Take this underneath its term. So it's 5 to the x like that. Now, once you have the 5 to the x's alone, then you can say let 5 to the x equal to k. So this is k is equal to 20 plus 5 times 5 squared. 5 squared is 25 times 5, it gives you 125 all over k. Right, I don't like fractions in my sum, so I'm going to find an LCD. The LCD is k, which means multiply every single term in your sum to k. This is k squared is equal to 20k plus 125. Right, this part disappears. Right, not disappears. When you multiply to k, it just cancels, right? Okay. That then gives me a trinomial. A normal trinomial, we have k squared minus 20k minus 125 is equal to 0. And then we're going to factorize it. So when we factorize it, it gives me k and k. It gives me 25 and 5. That's a minus, that's a plus. So k is equal to 25, or k is equal to negative 5. But k is equal to 5 to the x, right? So this is 5 to the x is equal to 25, or 5 to the x is equal to minus 5. This is no solution, because a positive base can never be equal to a negative number and can never be equal to a 0. So this is a positive base raised to any exponent, can never be equal to a negative solution. So you cancel that out. It can also never be equal to 0. Keep that in mind. Okay, this side we can make same basis. This is 5 squared. Your bases will now fall away. X is equal to 2. That's the solution there. Okay, right. Solve for x and y. First, we're going to have to take this out of log form because We don't know how to deal with that right now. So when we take, sorry. Okay, when we take this out of log form, we say it's this raised to this equal to this, right? This raised to that equal to that. So it's x to the power 4 is equal to 16. Then you're going to fourth root both sides. Then x is equal to 2. All right, so we have that. Then on the other side, because we have x already, we have y plus the root of, we know x is 2 plus 7 is equal to 2 plus 1. All right, that gives me y plus the root of 9 is equal to 3. That gives me y plus 3 is equal to 3. Take that over, y is equal to 0. And that's that. Okay, next. 1.4 says, calculate two numerical values of p for p so that x squared plus p into 2x plus 7 plus 8 is a perfect square. So perfect square means you have to complete the square, all right? So before we do anything, this is going to be, it's actually pretty simple, right? First, we need to get it in the form ax squared plus bx plus c, all right? So we have x squared plus p into 2x plus 7 plus 8, right? For me to get it to be a perfect square, I need to complete the square. So I'm first going to get it in the form ax squared plus bx plus c so that I can complete the square, right? Remember, completing the square is taking an equation that's in this form and putting it in the equation a into x minus b all squared plus q. Right, so I'm going to distribute, get rid of that bracket. That gives me plus 2bx plus 7p plus 8. This is now in the form ax squared plus bx plus c. That whole thing is c. So once we have that, I'm going to pull my a, b, and c values. So the a value is 1, the b value is 2p. Remember, the b value is everything except the x. Everything standing next to x, and the c value is everything that doesn't contain an x, which is that whole thing, which is 7p plus 8. Right, so to complete the square, we're going to go x squared plus 2px plus something minus something, and then bring down our c value. Right, how do I get these things? I take the b value, the coefficient of x, this. So to get this and this, we're going to take the b value, we're going to divide it by 2 and then square it. So the b value is 2p divided by 2, it gives you just p, and then square that answer, which is p squared. So it's p squared here, and it's p squared there, and you're not affecting the numerical value of the sum because plus something minus the same thing gives you 0, right? So at this point, these first three terms become a perfect square trinomial. So it gives me a bracket raised to the power 2. How do I fill in the bracket? You go square root of the first, sine of the middle, square root of the last. So square root of the first is x, sine of the middle is plus, square root of the last is p. And the remaining thing is minus p squared plus 7p plus 8. So now, for this equation to be a perfect square, it needs to have something that's raised to an even power. And that's it. You can't add anything to it. You can't subtract anything from it. So for it to be a perfect square, I need just this part of the sum to exist. Because if only this part of the sum existed, then this entire equation would be a perfect square because that entire bracket is raised to a 2, which makes it a perfect square. That means I don't want this part of the sum to exist at all. Meaning I want this yellow highlighted part to be 0. So make it equal to 0. So you say for a perfect square, I'm going to go minus p squared plus 7p plus 8 must be equal to 0. This part must not exist for this equation to be a perfect square, meaning I just want something raised to the power 2, which is just this part. That means I don't want this part to exist, right? So at this point, I have a trinomial. I'm going to factorize it. But before I do, I'm going to divide right through by minus 1. That's p squared minus 7p minus 8 is equal to 0. Then we're going to take this here. We're going to factorize the trinomial. We have p and p. We have 8 and 1, minus and plus. P is equal to 8, or p is equal to negative 1. So the question said determine two values of p, two numerical values of p, so that that entire equation is a perfect square, and that's how you do it. All right, wasn't so bad. The following sequence of numbers forms a quadratic number pattern: minus 3, minus 2, minus 3, minus 6, minus 11. The first differences of the given sequence also forms a sequence, which is an arithmetic sequence, right? Determine an expression for the nth term of the first differences. So remember, I told you, you must remember that the first differences of a quadratic number pattern will always form an arithmetic number pattern. So when we do this, these are the first differences. Minus 2 minus minus 3 gives me a positive 1. Minus 3 minus minus 2 gives me a minus 1. Minus 6 minus minus 3 gives me a minus 3. Minus 11 minus minus 6 gives me a minus 5. Right. This first differences is also an arithmetic sequence. Right? So they want the nth term, the general formula for this arithmetic sequence. You go Tn is equal to Dn plus Q. So you say D is the common difference between these, which what is happening is just minusing 2 the entire time, right? So your common difference is negative 2. N, Q is what you do to D to get the first term. What do I do to minus 2 to get to the first term, which is 1? So I need to add 3. If I add 3 to minus 2, it will give me 1. So your general term there is Tn is equal to minus 2n plus 3. All right. Calculate the first difference between the 35th and the 36th term of the quadratic sequence. So remember I taught you this theory. I said if you have T1, T2, T3, T4, T5 of the quadratic pattern, lies between T1 and T2 of the quadratic lies T1 of the arithmetic. Between T2 and T3 of the quadratic lies T2 of the arithmetic. Between T3 and T4 of the quadratic lies T3 of the arithmetic. Between T4 and T5 of the quadratic lies T4 of the arithmetic. So between T35 and T36 of the quadratic lies T35 of the arithmetic. So it says calculate the first difference between the 35th and the 36th term. Very simply, you're going to take your Tn of the arithmetic because they're talking about the first difference, which means the arithmetic sequence, right? You're going to take that Tn and you're going to sub in 35 for n. That's going to give you an answer of minus 67. And there we go. Right, next. Determine an expression for the nth term of the quadratic sequence. So, I just need this. Give me 1 second. All right. So to get the general term now of the quadratic sequence, remember we start at the bottom when we say 2a is equal to that, then we go 3a plus b is equal to that, and a plus b plus c is equal to that. right? And then we take each equation. So we have 2a is equal to minus 2, solve for a. A is equal to -1. Then we have 3a plus b is equal to 1. But a is -1, we just calculated it. Right? A is -1. So we have -3 plus b is equal to 1. So b is equal to 1. Take that -3 over. It's going to be a positive 3. So 1 plus 3 gives you 4. Then a plus b plus c is equal to -3. A is -1. B is positive 4. So we have -1 plus 4 plus c is equal to -3. That gives me a 3 plus c is equal to -3. Take that 3 over. C is equal to -6. Therefore, your final mark here, Tn is equal to an squared, an squared plus bn plus c. So you have Tn is equal to minus n squared plus 4n minus 6. That's the general term of the quadratic number pattern. It says, explain why the sequence will never contain a positive term. Now, remember, a quadratic number pattern or quadratic sequence, you must always look at in terms of a parabola. So, very simply, you're first going to calculate what the maximum point of this parabola is. Now, the maximum point or the minimum point of the parabola, right? In this case, this parabola, that's in the form y is equal to negative, let's go, negative x squared plus 4x minus 6. This is the equation of the parabola, right? When you look at it in terms of the parabola, you first need the turning point so that you can see what's happening, right? So you're going to calculate the turning point. It's x is equal to minus b over 2a. So minus 4 over 2 into a, which is -1, that gives me 2. So the x-coordinate of the turning point is at 2. Then you're going to take it, you're going to take the 2 sub back in place of x in the equation and get the corresponding y-coordinate of the turning point. So you have y is equal to -2 squared plus 4 into 2 minus 6. When you sub that in, it gives you a -2. So your turning point is here. And then I know that the graph is going to frown. I know that the graph is going to frown because the a value is negative. Sorry. Okay. So the graph is going to frown. It's going to look like this, which means, is this quadratic sequence ever going to experience any positive term? These are all the negative terms, right, that it experiences. It doesn't even experience these negative terms, right? So the graph is never going to experience a positive term, meaning any positive y value. It's never going to experience that because its maximum value is -2. Here's its maximum value. So you say its maximum value is -2. The 2 marks here is 1 for calculating the turning point, which is this point, 2 and -2. This is the 1 mark. And the other one is to say that the maximum is at -2, and so it will not experience any positive values. That's it. Okay. All right. The graphic below shows a dartboard from which patterns relevant to the different circles can be derived. The radii of the largest circle and and then moving consecutively to immediate inward circles is given by 18, 6 the root of 3, and 6 centimeters. The innermost circle has a radius of 2 over 3 centimeters. Show that the areas of the circles form a converging geometric sequence. This is very important. They said show that the areas of the circles form a converging geometric sequence. So very important. This sequence that's given to you is of the radii. You can't use that. You need to form a sequence with the areas of the circles. So the first circle, its area is pi r squared, but r is 18. Right? The second circle's area is pi r squared, but the radius of the second circle is 6 the root of 3 all squared. And the third circle is pi r squared, but the radius there is 6 squared. So we need that sequence first. That gives me 3, 2, 4 pi. It gives me 108 pi, and it gives me 36 pi. Right, so this is the formula, or not the formula, the sequence of the areas of the circles. Right? So now what we need to do is we need to prove that it forms a converging geometric sequence, which means that we need to prove that R lies between -1 and 1. So how do I calculate that? We're going to go R is equal to T2 over T1. T2 is 108 pi over T1, which is 324 pi. 324 pi. Right. That gives me an answer of 1 over 3. Right. So if it gives me an answer of 1 over 3, you need to end by saying, therefore, R lies between -1 and 1. Because R is a third between -1 and 1. And so the series is converging. There we go. Next, calculate the number of circles in the sequence forming the dartboard. The number of circles, calculate the number of circles in the sequence forming the dartboard. Okay, so here's the thing. We're going to go Tn is equal to AR to the n minus 1, right? Why am I doing this? Because I have the last circle's numerical value of its radius. So what I'm going to do is I'm going to look at this circle. Look at the dartboard. I know that the innermost circle has a radius of 2 over 3. So that means I can calculate how many terms are in the sequence, because this is just a weird way of asking how many terms are in the sequence. And so the way that I do that is with Tn, and I know that the last value of Tn is 2 over 3. So this is A. A is number of circles. So we're calculating with radius, or with radii, right? So the first term is 18. The radius is T2 over T1. So the radius is T2, which is 6 the root of 3 over 18. 6 the root of 3 over 18 gives me the root of 3 over 3. So the radius is the root of 3 over 3 all to the n minus 1, and n is what I need to solve for. So the first thing I'm going to do is I'm going to divide both sides by 18. All right, that's going to give me 1 over 27 is equal to the root of 3 over 3 all to the n minus 1. Right. There's two ways you can do this. You can make your bases the same, or you can use logs here. I'm going to use logs because it's easier. So I'm going to add the word log to both sides. All right. And then I'm going to bring down this exponent to the front. So it's going to look like this. You have log 1 over 27 is equal to n minus 1 log the root of 3 over 3. Then I'm going to divide both sides by log the root of 3 over 3. That's then gone. I'm left with n minus 1 here. This on the calculator is going to give you an answer of 6. All right, and so if it gives you an answer of 6, you need to take that 1 over. So that's 6 plus 1, which gives you 7. And so that's the total amount of circles on the dartboard. Okay. Okay, given the series 1 times 2, 5 times 6, so on and so forth, these are generally two sequences put together. So this is the first sequence, and this is the second sequence. All right, write the series in sigma notation. If we're looking at the yellow sequence, I'm going to pull it apart. That's 1, 5, 9, 13, and the last term there is 81. And then the other sequence is 2, 6, 10, 14, and the last term there is 82. Right. This is a arithmetic sequence, adding 4 the whole time. This is a arithmetic sequence, adding 4 the whole time. All right. So to get this general term, Tn is equal to Dn plus Q, and this one is also Tn is equal to Dn plus Q because they both arithmetic. D is your common sorry, your common difference, which is 4n, and then Q is what you do to D to get the first term. So what do I do to 4 to get to 1? Minus 3. All right, that's the first one. This one, again, the common difference is 4. Q is what you do to D to get the first term. What do I do to 4 to get to 2? Minus 2. All right, that's the general terms for the two sequences. So when you are writing in sigma notation, you're going to have here the yellow general term first, which is 4n minus 3. And then you're going to have the pink sequences general term, 4n minus 2. At the bottom is always n is equal to 1. And then on the top is the number of terms that are in the sequence. So to calculate the number of terms in the sequence, I just have to put the last term in place of Tn and figure out n. So this is 81 is equal to 4n minus 3. Take that minus 3 over. It's going to give me 84 is equal to 4n. Divide both sides by 4. N is equal to 21. Right? You can do the same thing here just to test it out, but it's going to give you the same answer. 82 in in place of Tn, and then solve for n. N is going to give you 21. So on the top of the sigma sign is the number of terms in the sequence, which is 21. Done. In the series, a plus ar squared plus so on and so forth, the sum to infinity is 1. In the series, where the terms are the squares of the above series, the sum to infinity is 5 over 6. Determine the common ratio. So first of all, I'm going to deal with the first one. You have a plus ar squared plus so on and so forth. The sum to infinity here is 1. So let's calculate the sum to infinity of this sequence. It's a over 1 minus r here is t2 over t1, which is just r, right? So that's just r. The sum to infinity for this sequence is 1 is equal to a over 1 minus r. Right. I'm going to cross multiply to make my sum simpler. That gives me 1 minus r is equal to a. Let's call this equation 1. Right. In the series where the terms are the squares of the above series. So we're looking at the next scenario here. We have a squared plus a squared r squared plus a squared r to the power 4 plus so on and so forth. The sum to infinity is 5 over 6. So the sum to infinity of a over 1 minus r, the sum to infinity for this sequence is 5 over 6. Your first term, this is your first term, is a squared all over 1 minus r. Let's figure out r. It's t2 over t1. So t2 is a squared r squared all over a squared. That and that cancels. We just left with r squared. So r is equal to r squared here. Right? Then I'm going to cross multiply to make my sum simpler. This is 5 into 1 minus r squared is equal to 6a squared. Okay, I'm going to replace this a with this because a is equal to that. It's equal to 1 minus r. So this is 5 into 1 minus r squared is equal to 6 into 1 minus r. Right, that gives me 5 minus 5r squared is equal to 6 minus 6r. And then I'm going to take everything over, have a 0 on one side. So I have 5r squared minus 6r plus 6 minus 5. That gives me 5r squared minus 6r plus 1. Factorize the trinomial. We have 5r and r, 1 and 1, both negative. So r is equal to 1 over 5, or r is equal to positive 1. But remember, if they're talking about sum to infinity, R can't be equal to this because sum to infinity has to occur for a converging geometric sequence, which means R must lie between -1 and 1, not equal to. R must lie between -1 and 1. There's no equal to on these inequalities for a converging geometric sequence, so it's no solution for this R, right? So that means to get the corresponding A, I'm going to take this R and subtract there. So that gives me 1 minus 1 over 5 is equal to, did I make a mistake somewhere? Hold on. Oh, I made a mistake. Hold on. Yeah. Give me 1 second. Right, this part here. This is A to B. I said A is equal to 1 minus R, right? But this A was squared, so we needed to square this part. Sorry, that's my bad. So distribute that in. That's 5 minus 5R squared. So this is 6 into first times first times last 2, last times last. Gives you that. Then distribute that in. So this is 6 minus 12R plus 6R squared. Right. Take everything over. So 6R squared plus 5R squared gives me 11R squared on this side. That's gone. Then we have minus 12R. 6 minus 5. Take this positive 5 over. It's going to give you a negative 5. So that's plus 1. And then you're going to factorize this. Sorry. That's 11R and R. That's 1 and 1. Minus and minus. So R is equal to 1 over 11, or R is equal to 1, which I told you that's no solution. This question just asked for the common ratio, so we don't have to sub back. Right, and so R is just 1 over 11. All right, okay. Breather, 1 second. All right, so question 4 says the graphs of the functions f of x and h of x are sketched below. F of x is a hyperbola, h of x is a straight line. Write down the values of p and q. Sorry. Okay, write down the values of p and q. P and q are the asymptotes. Right, p and q are the asymptotes. P with the opposite sign. So P is the vertical asymptote. It's this one. It's -2, but with the opposite sign when you put it into the equation, so it's a +2. So P is equal to +2. And Q is the horizontal asymptote, this one. So Q is equal to -1. The horizontal asymptote keeps its same sign, right? Okay. 1 second, sorry. Okay, next. It says calculate the value of A. So A is this value. So all we need to do is find a set of coordinates that lies on this graph, i.e. the hyperbola, and sub in for x and y and solve for A. So if we have the equation y is equal to A over x minus +2, sorry, minus 1. We need a set of coordinates that lies on the hyperbola. It's that set. We're going to sub it in place of x and y and solve for A. So we have -5 over 2 is equal to A over -4 plus 2 minus 1. That gives me a -5 over 2 plus 1 is equal to A over -2. That gives me -5 over 2 minus 3 over 2 cross multiply. Right, it gives me that. Cross multiply and solve for A. It's going to give me A is equal to 3. Right, next says write down the range of F. Now F is this graph. Right, the range is the vertical existence of the graph. So how far up and how far down does the graph go? It travels forever up, it travels forever down. What y values does it hit? It is every y value going upwards, every y value going downwards. But there is one y value that it doesn't touch, and it's this y value of -1. So how do we answer the range there? We say it hits every y value, meaning it travels forever up and forever down. How do we say that? Y is an element of real. But there's one y value that it does not hit, and that is -1. The next question says, determine the equation of the line of symmetry of f for which the gradient is negative, less than 0. So this is the bean method one that I told you guys about. So this is y is equal to, we have 3 over x plus 2 minus 1. This is the equation of the hyperbola. I told you, in order to get the axis of symmetry of the hyperbola, use the bean, right? So if they want the 1, so we start y is equal to x, or y is equal to minus bracket x, and then add the bean, plus 2 minus 1 plus 2, close the bracket, minus 1. This gives me y is equal to x plus 1. This gives me y is equal to minus x minus 2 minus 1, which gives me y is equal to minus x minus 3. They don't want this one. They want this one, the one that has m, the gradient, as a negative. So your answer here is simply y is equal to minus x minus 3. Okay, write down the equations of the asymptotes of f of x plus 4.5, which means that this is a horizontal movement because you're adding to x. It's a horizontal translation to the left movement, 4.5 units to the left. So if the equation of the vertical asymptote is at x is equal to minus 2, right? So if it's at x is equal to minus 2 and this graph is being shifted 4.5 units to the left, then your x asymptote is now going to be at 6.5, negative 6.5. Negative 6.5. Hold on. All right, I'm going to say that again. Your vertical asymptote is at minus 2. This graph is shifting 4.5 units to the left. So that's going to land me at an asymptote of minus 2 minus 4.5, which is at minus 6.5. Nothing happens to this asymptote because the movement is only left and right. And so the the horizontal asymptote stays the same. It's y is equal to minus 1. Okay. All right. That's that. Next one. Question 5. Given f of x is equal to 2x squared minus x minus 15, that's a parabola. G of x is equal to 3x minus 9 over 2 is a straight line. And h of x is equal to log x base a third. That is your inverse of a exponential graph. All right. Write down the coordinates of the turning point of f. Simple enough. You go x is equal to minus b over 2a. That gives me minus into minus 1 over 2 into a, which is this. We're looking at this, right? This is a, that's b, that's c, right? That gives me a positive 1 over 4. Take that sub back in. So we have f of a quarter is equal to 2 into a quarter all squared minus a quarter minus 15. Punch that in on the calculator. It gives you minus 121 over 8. So your turning point's coordinates, write it down nicely because they asked you for a set of coordinates, is a quarter and minus 121 over 8. That's the turning point's coordinates. Show that the x coordinates of the x-intercepts of f are minus 5 over 2 and 3 respectively. So how do you find x-intercepts? You make y equal to 0. Right, so we're going to take f of x's equation, we're going to make y equal to 0, and we're going to factorize the trinomial. 2x squared minus x minus 15. That's going to give us 2x and x, and 5 and 3. That gives me a negative there and a positive here. Right, so x is equal to negative 5 over 2, or x is equal to 3. Done. Okay. All right, next one. Sketch the graphs of f, g, and h below. Clearly label all the intercepts of the axis and the asymptotes where necessary on the graph. Okay, let's pull the graphs equations. All right, we're looking at that. Like Cartesian plane. All right, we're going to draw the parabola first. We're going to draw f first, right? With f, we said that the x-intercept is at minus 5/2, which is negative 2.5. Negative 2.5, and at 3. That's minus 5/2 and at 3. All right. The y-intercept is this number. It's at negative 15. We use a scale, more or less. Let's go in fives. 5, 10, 15. It's the y-intercept. And then the turning point was at 1/4 and minus 121/8. This, if you SD it on the calculator, gives you negative 15 and an eighth. All right, so negative 15 and an eighth. So we're going to go to 1/4. So it's somewhere here, somewhere there. That's 1/4. And minus 15 and an eighth, let's say it's somewhere there. So that's the minus 121/8, right? That's your turning point. 1/4 and minus 121/8. Oh my. Okay, that's f of x. It's the first graph, right? Second graph is a straight line. Your y-intercept is here at minus 9/2. 9/2 is 4.5. So negative 4.5 is somewhere here. Let's say minus 9/2 is there. And then to get the x-intercept, you make y equal to 0. Because remember, to draw a straight line, you need a y-intercept, you need an x-intercept for y is equal to mx plus c. So to make y equal to 0, that's 3x minus 9/2. I'm going to take that over. That's 9/2 is equal to 3x over 1. Cross multiply, that gives me 6x is equal to 9. Divide both sides by 6. X is equal to, that's 3/2, which is 1.5. So 1.5 is there. So a straight line is going to look like that. Right? That's g of x. And then the last one is the opposite of your exponential graph. So the first thing is an exponential graph. The inverse of it is going to be y is equal to 1/3 to the x. This is the exponential graph. So the first thing of the exponential graph is you draw its asymptote. Its asymptote is going to be on the x-axis. So the logs graph is going to be on the y-axis. The logs asymptote, is going to be on the y-axis instead of the x-axis. Then the next thing that you do for the exponential graph is to find its y-intercept by making x equal to 0. So when we take this equation, y is equal to 1/3 to the 0, this gives us 1. So the y-intercept for the normal exponential graph is at 1, which means that the inverse, the log graph's x-intercept is going to be at 1. So it's there, right? Then you find a set of coordinates by making x equal to 1 for the normal graph. So you have y is equal to 1/3 to the 1, which gives me 1/3, which means my set of coordinates is 1 and 1/3 for the normal exponential graph, which means that the log graph's set of coordinates is going to be 1/3 and 1. So we're going to go 1/3 and 1 is here. And so the graph will look, remember, don't cut through the asymptote. The graph will look like that. All right, this is h of x. And that's it. It's not so bad. That's the graph. Okay, let's move on. Okay. 5.4 was this abscissa question. They took it out. They asked us to mark it without this question, but it wasn't a difficult question. Abscissa just means X value, and the length of HR, of line HR, was just a vertical distance between two graphs. So all you had to do was go HR is equal to top graph minus bottom graph, and then sub in the X value to get the length of HR. It was pretty simple, right? Okay. Write down the domain of the inverse. So I needed this graph. Right. The domain of the inverse of the log graph. So if you're looking at the log graph, which is h of x, first ask yourself what's the range of it. So what's the range? Because this question is asking you for domain, right? So domain of the inverse of h. So if you want the domain of the inverse of h and you just have h, ask yourself what is the range of h, and then automatically you'll have the domain of the inverse. Because remember, x is swapped to y's, domain swaps to range, range swaps to domain for inverses. So if I ask myself what is the range of the original graph, the range of this graph is remember the range of a graph is the horizontal, not the horizontal, the vertical existence of the graph. So if I'm looking at this graph, it's traveling forever up and forever down. Yes, it's traveling to the right, but it's also traveling down at this point, right? So it travels forever up, forever down without any restriction, which means that the domain of the original graph is y is an element of real. That's the range of this h of x, which means that the domain of the inverse will be x is an element of real. So this part stays the same. You just swap to an x because they're talking of domain. Again, one more time. If they want the domain of the inverse, you have to ask yourself what is the range of the original. The range of the original, you look at the graph, you say it's traveling forever up, forever down. So the range is that it touches every single y value. So y is an element of real. But because you are now swapping it around, you swap x's to y's, y's to x's, and that will now give you x is an element of real. Okay? Okay, I hope that made sense. Then they're asking for the range of the inverse. Very simply, again, you look at the graph. If they're asking you for the range of the inverse, you now have to ask yourself what is the domain of the original. So if we're looking at the domain of the original, you're now looking at the horizontal existence of the graph. How far to the right and to the left does the graph travel? So if we're looking at the horizontal existence of the graph, this graph only has this horizontal existence. It doesn't go before this asymptote, right? So the domain of this original yellow graph is that x is greater than, meaning it only travels this way, right? Horizontal existence. It doesn't go before this line. So the domain, follow the arrow, look, right? Is x is greater than whatever this line is that it starts at. So it starts at 0. You're not going to put an equal to because this line is an asymptote. So it doesn't ever touch that line. So your domain of this original graph is x is greater than 0, which means when I'm trying to answer the range of the inverse, I swap x's to y's, y's to x's. So that's now going to be y is greater than 0. That's it. Okay. Remember, domain must be answered in terms of x, range must be answered in terms of y. Don't forget that. Determine the values of k if the roots of 2x squared minus x plus k is equal to 0 are equal. 4 equal roots. This is nature of the roots question. For equal roots, delta must be equal to 0, which means b squared minus 4ac must be equal to 0. Pull your a, b, and your c values here. make sure that your equation is in the form ax squared plus bx plus c is equal to 0. You have to have that equal to 0 on the other side. Your a value is 2, your b value is -1, your c value is k. So now you're going to go b, which is -1 all squared, -4 into a, which is 2, into c, which is k, is equal to 0. This gives me 1 minus 8k is equal to 0. Negative 8k is equal to -1. Divide both sides by -8. Then k is equal to positive 1 over 8, because negative divided by negative is going to give you a positive. And that's the answer to that. Simple. Determine the maximum value of g of x, right? In paper 1 and paper 2 sometimes, but mainly in paper 1, the word maximum and minimum, find the derivative, make it equal to 0. It's an optimization question, and it can come out in any section. It doesn't matter. It doesn't have to be in calculus. It can be in any section of this paper. The second you see the word maximum or minimum, it's an optimization question. You need to form an equation that you can find the derivative of and make that derivative equal to 0. So all we're going to do right now, it says determine the maximum value of g of x minus f of x. Let's just take these equations. Right. So we're going to go g of x minus f of x. G of x's equation is 3x minus 9 over 2 minus f of x's equation. Keep a bracket because you're subtracting more than one term, minus 2x squared minus x minus 15. Then this is going to give me 3x minus 9 over 2 minus 2x squared plus x plus 15. Add your like terms. That's going to give me minus 2x squared. That's going to give me plus 4x. That's going to give me, I have no idea. 1 second, let me punch this in. Negative 10 and a half. No, it's not 10 and a half. Yeah, it's 10 and a half. Okay, right. And then at this point, I'm going to find the derivative of this equation because I can't simplify any further. So the only thing I did was substitute the equations of g of x and f of x in place of g of x and f of x. And I formed an equation that I couldn't simplify any further. At that point where you can't simplify any further, you need to find the derivative. Now, if I find the derivative of this, it's going to give me negative 4x plus 4. Find the derivative and then make it equal to 0. There's no implied 0. You have to make it equal to 0. You must show them this part. And then solve for x. So you have minus 4x is equal to minus 4. Divide both sides by minus 4. That's going to give you, it's going to give you x is equal to 1. Then you take this and you sub back into this equation of that last step where you couldn't simplify any further. Not sub back into the derivative, that's wrong. Sub back into the original. Either the original, the first step, or this last step where you couldn't simplify any further, that's the same thing, right? So you're going to have the max value is equal to minus 2 into 1 all squared plus 4 into 1 minus 10 and a half. Then that's going to give you 12 and a half, and that's the maximum. So again, when you see the word maximum and minimum, find the derivative and make it equal to 0. The derivative of what? They'll tell you. They're giving you this, you sub in the equations, you get an equation in terms of x, in terms of whatever it may be. Once you can't simplify that equation anymore, so you sub in the equations, you simplify it. At the point that you can't simplify anymore, you find the derivative because of this word maximum or minimum, or any synonym to maximum or minimum. You find the derivative, you make it equal to 0, you solve for x. That is not yet your answer. That's the thing that will produce the maximum or minimum. So you take this answer, you sub it back into the original equation to get the actual maximum or minimum value. Okay. Right, next. Question 6. It says f of x is equal to 3 to the power x. Determine the equation of the inverse in the form f to the minus 1 of x. So we have a y is equal to 3 to the power x. Swap x's to y's, y's to x's. That's your first mark there, probably. No, it's not. There is only one mark. It's for the equation. And then put this in log form. It's going to be f to the minus 1 of x is equal to log x base 3. That's the answer. Okay, and make sure to give it in this form if they ask it in that form. Sometimes they say in the form y is equal to. Then you have to give it in y form. Sketch the graphs f and its inverse clearly show all intercepts with the axes. Simple enough. All right, I'm going to draw the exponential graph first. We have y. This is f of x. So it's y is equal to 3 to the x. I told you first the asymptote. In an exponential graph, the asymptote is on the x-axis. It's the loose number at the back, which in this case is 0, right? It's on the x-axis. Then I said find the y-intercept. There's always only 3 steps. Asymptote, y-intercept, set of coordinates, draw, right? And then the inverse will just be everything swapped around. So we have the asymptote drawn in. We need a y-intercept by making x equal to 0. We have y is equal to 3 to the power 0. That gives me 1. So my y-intercept is here at 1. Then I need a set of coordinates by making x equal to 1. So those are the 3 steps. Asymptote, y-intercept, set of coordinates. Right. So set of coordinates by making x equal to 1. We have 3 to the power 1. That gives me 3. My set of coordinates is 1 and 3. I'm going to plot 1 and 3 goes there. That's 1 and 3. Make sure you don't pass through the asymptote. So the graph will look like that. That is f. The inverse, everything is just going to swap around. I don't need any calculation. I just need everything to swap around. Sorry, I'm dying. Okay, so what was the horizontal asymptote is now the vertical asymptote. What was a y-intercept of 1 is now an x-intercept of 1. And what was a set of coordinates of 1 and 3 is now a set of coordinates of 3 and 1. Everything just swaps around. Make sure you don't pass through the asymptote. So this is f to the minus 1 of x. And that's the two graphs. Okay, write down the equation of the line of symmetry between the two graphs. The line of symmetry is this line. This is the line y is equal to x. Right. So we say this is y is equal to x. That's the answer there. For which values of x will f of x times its inverse be less than and equal to 0? Right. Here's what we're going to do. I'm going to take this equation. I'm going to take this graph. Let's duplicate it, make it smaller. Pull it here. All right. And let's look at it. So they're saying f of x times its inverse must be less than or equal to 0, which means less than or equal to 0 meaning negative. What times what gives you a negative? Either a negative there and a positive there, or a positive there and a negative there. So we're looking for a solution where one is positive and one is negative in order for it to produce a negative solution. So how do we do this? We label the graphs with pluses and minuses. So wherever a graph lies above the x-axis, it will be positive. So this graph always lies above, so it's always positive. This graph always lies above the x-axis, it's always positive. This graph lies above here, right? And then it's below here, right? And at this point, hold on, I just need to see. Okay. Right, at this point, we need to see the change in signs, right? The only place that the signs change is here. So I'm going to draw a line on that. All right, that line is at x is equal to 1. So that's the change in sign where it goes from a negative to a positive for this graph, right? So we are looking for a solution where one of the graphs is positive and one of the graphs is negative. So if I'm looking at this zone, right? If I'm looking at this zone and I'm looking at the two graphs, the pink graph and the blue graph, in this zone, after x is equal to 1, they're both positive. So in this zone, after x is equal to 1, they're both positive. Then there's this zone between the two. And then there's this zone after that line of the y-axis, in which the blue graph doesn't exist. So I'm going to say that again. There's this green zone where both the pink and the blue graph is both positive, and that's not a solution that I'm looking for, because I want one to be positive and one to be negative in order to produce a negative solution, right? So that's not a zone. Between x is equal to 1 and x is equal to 0, because this is the y-axis here, right? So between x is equal to 0 and x is equal to 1, one of them is positive and one of them is negative. So within that blue zone, right? One is positive, one is negative. That's a solution. And then this zone here before x is equal to 0, only the pink graph exists. So I can't answer in terms of the blue graph there, which means my solution is here between 0 and 1, where one of the graphs is positive, meaning lying above, and the other graph is negative, right? And that's the solution that I'm looking for. So when I answer it, I say it's between 0 and 1. Smaller number first, bigger number second, x in the middle, and always your inequality must face this direction, both of them. There's never going to be a scenario where one faces the one way and the other one faces another way. They must both face the margin as long as the smaller number is on the left, right? Now, with regards to equal to, because the question has an equal to. Whichever one of the x values is an asymptote, that one will not get an equal to, and the other one, if it's not an asymptote, it will get an equal to. So if we're looking at this, x is equal to 0 is an asymptote, that one will not get an equal to sign, and x is equal to 1 was not an asymptote, so that one will get the equal to sign. So this is an equal there, no equal there, that's your solution. Between 0 and 1 is where you'll have one positive and one negative solution. Okay. I hope that made sense. Write down the range of h of x is equal to 3 of minus x minus 4. So this this graph is pretty simple, actually. When you're sketching it, and you should sketch it in your mind, right? The asymptote is at minus 4. It's this loose number at the back. So it's at minus 4. Then you need to find the y-intercept to see if the graph lies above or below that asymptote. So you take the equation y is equal to 3 to the minus x minus 4. You find the y-intercept. You find a y-intercept by making x equal to 0. So you have y is equal to 3 to the minus 0 minus 4. Right? That gives me 1 minus 4, which gives me a negative 3, which means that the y-intercept is here. It's at minus 3. So the graph's either going to go this way or it's going to go this way, but it's never going to go below that. It's never going to be anywhere here, because the y-intercept lies above the asymptote, and the asymptote is at minus 4. So if the graph lies above, either like this or like this, it doesn't matter. The fact of the matter is that it does lie above minus 4, because the y-intercept is above the asymptote. So we'll say that the range is y is above, greater than minus 4. No equal to, because minus 4 is the asymptote. Okay, so above minus 4, and that's the answer there. Okay, write down an equation for G. If the graph of G is the image of graph of F, of the graph of F, after F has been translated 2 units to the right and reflected about the x-axis. So let's take f of x's equation. It's 3 to the power x. So we have y is equal to 3 to the power x, right? It's been translated 2 units to the right, 2 units to the right, and then reflected about the x-axis. 2 units to the right means subtract from x. So you're going to say x minus 2, and then it was reflected about the x-axis, meaning change the sign of y. So those are the 2 transformations. And now you need to make sure, remember, we don't ever give an equation that's not in positive y form. So I'm going to divide both sides by negative 1. So that's going to give me y is equal to minus 3 to the x minus 2. And that's G of x's equation. Minus 3 to the x minus 2. Done. Okay, next. Okay, all the functions are done. Okay, a business buys a machine that costs 120,000 Rand. The value of the machine depreciates at 9% per annum according to the diminishing balance method, which is basically the reducing balance method, which is the to the power n formula. Determine the scrap value of the machine at the end of 5 years. You're going to use your normal A is equal to P into 1 minus I to the power n because of diminishing balance. So you have your value of 120,000 of the machine. 1 minus the depreciation is 9%. Don't forget your percentage sign at the end of 5 years. All right. Straight punch into the calculator gives you 74883,86. All right, that's that one. Then it says after 5 years, the machine needs to be replaced. During this time, inflation remained constant at 7% per annum. Right, inflation is A is equal to P into 1 plus I to the power n. It's the compound interest formula, right? Determine the value or the cost of a new machine at the end of 5 years. It's still 120,000 into 1 plus the inflation rate is 7%. This is all to the power 5. Remember this one with inflation and depreciation is not, you don't have to divide the interest by anything and multiply the number of years by anything. It's a yearly inflation and depreciation rate. So these are not divided or times to anything for both of them, for inflation and depreciation. Right. Okay, straight punch into the calculator gives you 168,306,21. Right, that's that one. It says the business estimates that it will need approximately 90,000 by the end of 5 years. A sinking fund for approximately 90,000 into which equal monthly installments must be paid is set up, which means that the sinking fund is worth 90,000. Regardless of anything else, they are setting up a sinking fund for 90,000 Rand. Okay, so we don't do any of the other drama where we normally do the subtraction of the inflated rate minus the scrap value of the old machinery. We don't do that in this question because they're telling us that the sinking fund was set up for 90,000. So we're not doing a subtraction in this question. Interest on this fund is 8.5% per annum compounded monthly. The first payment will be made immediately, which means there's no 1 month's grace here. And if it's made immediately, meaning in the start of a month, and the last payment will be made at the end of the month. So if your first payment is not being made at the end of a month and the last payment being made at the end of the month, that means you have an extra payment. I'm going to say that again. If your first payment is not being made at the end of the month and the last payment being made at the end of the month, if that happens, then you have a perfect amount of payments without any added payments. If it's made at the end of the month, the first payment, and the last payment is made at the end of the month, then there's no added payments. It's a perfect amount of months. But if you are starting immediately means at the start of the month, and your last payment is made at the end of a month, then that means there's an added one added payment. Let me say that one more time. You are not taking into account your 1 month's grace for this scenario because they said payments start immediately. So it's starting in the start of the month and you are ending at the end of a month. That means there's an added payment. So let me explain N nicely. If you start at the start of a month and you end at the start of a month, there's no added payment. If you start at the end of a month and you end at the end of a month, there's no added payment. But if you start at the start of a month and you end at the end of a month, then there's an added payment. So if you start at the start, the first payment is at the start, last payment is at the start of the last payment is at the start of the last month, then this is no added payment. So first payment at the start of the month, last payment at the start of the month, no added. If the first payment is at the end of the first month and the last payment is at the end of the last month, end and end, no added payment. Right? But if the first payment is immediately, start, and your last payment is being made at the end, then you have one added payment, one singular added payment. Depends on the scenario, obviously. But in this case, this is the basics of end, right? Start and start, no added payment. End and end, no added payment. Start at the start of a month and end at the end of the last month, that's an added payment. So if you're looking at this question, it says the first payment will be made immediately, which means in the start of the month. And the last payment is being made at the end of the 5-year period, which means you're starting and you're ending, there's an added payment. You started your first payment at the start immediately, and you ended your last payment at the end of the last month. That's an added payment, right? So calculate the value of the monthly payments into the sinking fund. I hope this made sense. I hope this is a bit of a guide. Okay, so we're going to go that we have the future value formula, because sinking fund is F formula. F is equal to X into 1 plus I to the power N minus 1 all over I. The sinking fund was set up for 90,000. Don't do the subtraction because they told you the sinking fund is set up for 90,000. X is what we're trying to solve for, because it says calculate the monthly payment, into 1 plus I is 8.5%. It is compounded monthly, all to the 12 times 5. 12 times 5 is 60, plus the one added payment, because it started immediately. Right? So there's 61 payments minus 1 all over 8.5% over 12. Right. This is simply a matter of taking 90,000 and dividing by the box. This is the box. So no bits and pieces. You take 90,000, you press the actual divide button on your calculator, and then you punch in this box. All right? And then that gives you X's value to be 1184.68. Okay. Right. Kasala receives an amount of 900,000 upon her retirement. She invests this amount immediately. Right. This is a lump sum that you are receiving, or she is receiving, in the present, today. She receives an amount of 900,000, a lump sum in the present, which means you have to use the present value formula. Upon her retirement, she invests this amount immediately at an interest rate of 10.5% per annum. Compounded monthly, she needs an amount of 18,000 per month to maintain her current lifestyle and plans to withdraw the first amount at the end of the month. She's taking that 1 month's grace, which is perfect, right? For how many months will she be able to live off of her investment? So you're going to start with E is equal to X into 1 minus 1 plus I to the minus N all over I, right? Your P is the 900,000, the lump sum that she's receiving at present. She needs 18,000 a month, right? That's the 18,000 into 1 minus 1 plus 10.5% over, it's compounded monthly, all to the minus N. That's what I'm looking for, right? N is the number of months. We're looking for that. This is all over 10.5% over 12. Right. How do I solve this? Now, keep in mind the logs here. You're going to get a mark for proper simplification. So make sure you memorize the steps to doing these logs. And you only use logs when you're solving for N. So make sure you memorize how to solve it. Memorize the steps. The first thing is you take the 900,000 and you divide by the bean. Right? So 900,000, press the divide sign on your calculator and punch in the bean. That's going to give you 7 over 16. Right. Then you're going to take 7 over 16 is going to give you a 1 minus 1 plus 10.5% over 12, all to the minus N. This is what you're left with, right? You're going to take this 1 over, right? It's going to be a minus 1 on this side. So it's 7 over 16 minus 1 is equal to minus 1 plus 10,5% over 12, all to the minus n. Then this is going to give you a minus 9 over 16 is equal to minus this whole bracket again. Right, divide both sides by -1, then the negatives are going to go away on both sides, right? At this point, you can't make your bases the same, so we add the word log to both sides of the equation. And we bring this minus n exponent to the front. So it now looks like this. We have log 9 over 16 is equal to minus n log 1 plus 10,5% over 12. Now, when you're solving for n, you are going to divide by everything on that side apart from n, including the negative. So you're going minus log 1 plus 10,5% over 12. And what you do to one side, you must do to the other side. Okay, so what's going to happen here is the negatives are going to fall away. This is going to fall away. You're just left with n on that side. So you have n. This whole thing goes in the calculator. No bits and pieces. The whole thing, as you see, it goes in on the calculator. It's going to give you 66,043, which means that she will be able to sustain this for 66 to 67 months. They accepted both of those answers. So you say n is equal to 66 or 67. Any one of these two answers that you gave, they accepted. Okay. And that's that. That was finance. The finance wasn't too bad in this paper at all, actually. All right. On to calculus. Determine f prime x from first principles. The first thing you need is f of x plus h. So this is f of x. I need f of x plus h, which means wherever I see an x, I'm going to replace it with x plus h. That's squared plus 1. Simplify. Minus 2, you can't distribute into that bracket. You cannot distribute into a bracket that's not raised to the power 1. So first, square that out. First times last times 2, last times last. Then distribute into the bracket because the bracket is now raised to the power 1. That gives me minus 2x squared minus 4xh minus 2h squared plus 1. Right, that's f of x plus h. Then f prime x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Right, and then you're going to sub in. So this is the limit as h tends to 0. F of x plus h is this whole drama. So we have minus 2x squared minus 4xh minus 2h squared plus 1 minus f of x, which is this. So keep a bracket when you're subtracting more than one term. That's all over h. Right. Keep bringing down the limit until you sub h to be 0. So this gives me minus 2x squared minus 4xh minus 2h squared plus 1 minus, that gives me a positive 2x squared minus 1 all over h. Minus 2x squared plus 2x squared cancelled, plus 1 minus 1 cancels. We're just left with the limit as h tends to 0 of minus 4xh minus 2h squared all over h. Pull out h as a common factor on top so that it can cancel with h as a denominator at the bottom. So this is h into minus 4x minus 2h all over h. The h's are now going to cancel. And in this step, you can drop the limit because in this step, I'm going to replace the h in my equation with a 0. So only in the step where you are replacing the h to be a 0 can you then drop the limit, and then you get your answer of minus 4x, and that is f prime x using first principles. You can also find the derivative directly from here to make sure that you actually did first principles correct. So 2 times minus 2 gives me minus 4. X, subtract 1 from the exponent is just 1, and then this part falls away. So if this and this ends up being the same thing, then you know you did your first principles correctly. All right. Next one. Hence, calculate the gradient of the tangent to f at x is equal to minus a half. So to calculate gradient, remember f prime x stands for gradient. This is f prime x that you were calculating. F prime x is the gradient. This is the gradient, right? For the equation of a tangent anywhere on a curve. So it says, hence, calculate the gradient of the tangent to f at x is equal to minus a half. So we had this. So you just say f prime minus a half is equal to minus 4 into minus a half. And that gives you an answer of 2. And so the gradient is 2, where x is equal to minus a half. Okay, moving on. Determine the derivative of f of x is equal to the cube root of x squared plus 1 over 4x to the power 4. First, you need to make sure that there's no x's, or the variable you're differentiating is not under a surd, it's not the denominator, all of the rules of before finding the derivative. So before we do anything, I'm going to take this out of surd form. It's x to the 2 over 3, inside over outside, right? Plus 1 over 4. Leave the 4 alone. It's got nothing to do with the x. Don't touch the 4, right? They're not attached. This 4's exponent is positive 1. You leave it at the bottom. You take this one up. And just take it up to the side. It's good enough. So you can take it up to the side. Whatever's on the side of a fraction belongs to the numerator. I told you that already. So this is taking up to the side, and it's going to be a minus 4 when you take it out of the denominator. So we have that at that point. Now you can find the derivative. You're going f prime x, change the notation, find the derivative of everything in one step. So 2 over 3 times 1 gives you 2 over 3. X to the 2 over 3 minus 1 gives you minus 1 over 3. Then this one is minus 4 times 1 over 4 gives you a minus 1. X to the minus 5. So remember, exponent times coefficient, and then subtract 1 from the exponent. Exponent times coefficient, subtract 1 from the exponent. And that's how you do that. Okay. This one people were saying were a little difficult, but I just can't see that it could be difficult. It's quite simple. It says you're given h of x is equal to ax squared. So this is the equation that you're given. H of x is equal to ax squared, where a is a positive number, right? It then says determine the value of a if it is given that h to the minus 1, which is the inverse of h, of 8 is equal to h prime 4. So here's what I want you to do. I want you to split the two scenarios. You have h to the minus 1 of 8. And here you have h prime 4. So first of all, let's ignore this 8 for right now. And let's ignore the 4 for right now. Let's just put an x and an x there. Right? We're coming to it. We know that this is supposed to be 8. We know that this is supposed to be 4. We'll get there. But right now, let's just look at this part. They're saying find the inverse of this, right? So we have the normal equation to be this. This is the normal equation, right? And this is saying find the inverse. So swap x's to y's, y's to x's, like that. And then get it into y form to get this, right? So you're going to divide both sides by a. So you have x over a is equal to y squared, then square root. That gives me the square root of x over a is equal to positive y. Right. This positive y is this graph. H to the minus 1 of x. Right? That's at that point. You just found the inverse. And this one is a prime. So you have the equation, the basic equation, this, right? And they're saying find the derivative of this. So to find the derivative, it's dy over dx is equal to exponent times coefficient, and then subtract 1 from the exponent. So exponent times coefficient gives me 2a x, and then subtract 1 from the exponent is just 1. So we leave it at that. That means that this is h prime x. All right, because this is normally given. Let's change that notation. This is the normal h of x. This is h prime x. All right? Sorry. All right. So at this point, you have the inverses equation, and you have h prime x's equation, right? And they're saying that these two are equal to each other. So you're going to go that this part is equal to this part. So we're going to go that the root of, okay, before we do that, let's say we're going to sub in the 8 and the 4 in place of the x's. So this one needs an 8 in place of the x. So it's 8 over a is equal to h to the minus 1 of 8, because you're replacing the x with an 8, right? So we replace the x's with an 8 for this equation. And for this equation, they replace the x with a 4. So this is h prime 4 is equal to 2a4. And then they're saying at this point, h to the minus 1 of 8 is equal to h prime 4, which means this part is equal to this part. This and this is equal. They told me so, right? And so at this point, the only unknown is a, and that's what they wanted me to solve for. So I have the root of 8 over a is equal to 4 times 2 gives you 8a here. I'm going to get rid of that root because it's stressing me out. But what you do to one side, you must do to the other side. That gives me 8 over a is equal to 64a squared. Then again, another thing that's stressing me out is a fraction. I hate fractions in my sum, so I find an LCD, meaning I multiply everything in the sum to the denominator that's in my sum. If I multiply this whole thing to a, the a's will cancel, so I'm just left with 8 on this side. And this side, what you do to one side, you must do to the other. So you must also multiply that to a, and that will give you 64a cubed. Now you solve this equation. I'm going to divide both sides by 64. That gives me 1 over 8 is equal to a cubed. Then you cube root both sides. It gives you 1 over 2 is equal to a. So a is equal to a half. Yes, there was some sort of mathematical algebraic manipulation, sure. But the essence of the sum was not difficult. It was quite simple, actually. All right, that was that. Question 9. The graph of the function f of x is equal to minus 2x cubed plus a x squared plus bx plus c. In the video where I teach this section, I said be careful of this. And I hope you go back to that video and watch that explanation on that again. Is sketched below. The following properties of f are given below. Point A is 1 and 0, and it's a stationary point, meaning a turning point. Let's look at it. Okay, we got it. That's a turning point. Point B, 4 and 0 is an x-intercept. Got it. Point B is the point of inflection or the point of concavity. Point C is a turning point. Got it. And point D is the y-intercept. Got it. Easy, easy, easy. Show that A is 12, B is minus 18, and C is 8, which is a fancy way of them saying find the equation of this cubic function. So we have the equation of the cubic function to look like this: minus 2x cubed plus ax squared plus bx plus c. Right, they confuse you. Again, I'm going to say they confuse you because normally the a is here. But know that your a value is technically given to you. It's minus 2, right? Although they're calling this a, the proper a value of the original equation, ax cubed plus bx squared plus cx plus d, that a value of that original equation is given to you. It's negative 2. They're giving it to you. It's minus 2. So very easily, all we're going to do is we're going to start off. Remember, I told you there's 6 ways of finding the equation of a cubic function. This one, where you have one of the turning points, or you have the x-intercepts, and one of the x-intercepts is a turning point, you start off like this. You say y is equal to a into x minus root 1 into x minus root 2 squared. Right, we have the x-intercepts, right? This a value is this one. It's that minus 2, right? X minus root 1. The first root is the one that is not a turning point. So it's this one. So the root 1, the one that's not raised to the power 2, is the one that is not a turning point. So this has to be minus 4, because this is not a turning point and this bracket is not raised to the power 2. So that one is the minus 4. And the one that is an x-intercept and a turning point must be in the bracket that's raised to the power 2. So this one is an x-intercept and a turning point. It must go in this bracket that's raised to the power 2. Okay? So this is x minus 1 all squared. And then you're going to distribute all of this out, and you're going to get your values in the form y is equal to ax cubed plus bx squared plus cx plus d. And then you'll have all your values that are missing. Yeah. So let's do that quickly. All right. First, I'm going to leave this alone. I'm going to square this out. First times last times 2, last times last. Then I'm going to distribute this bracket in. That's going to give me, and I'm going to leave this minus 2 alone. So that's going to give me x cubed minus 2x squared. Then I minus 2x squared, x cubed minus 2x squared plus x minus 4x squared plus 8x minus 4. Right? Then we're going to add our like terms in that bracket. Gives me x cubed. The x squared is minus 6x squared. The x's are plus 9x. And the constant is just minus 4. And now I'm going to distribute that minus 2 in. Gives me minus 2x cubed plus 12x squared minus 18x plus 8. And now you'll see that this value for a is equal to 12, which was here, the coefficient of x squared is here. It's 12. And they asked us to prove that it's 12. Then the b value, which is the coefficient of x, they asked us to prove it's minus 18. Here's the coefficient of x being minus 18. And they said the c value must be 8. And here it is as 8. And there we go. As simple as that, right? Okay. Study. Still dying. Okay. It says Kusal states that a tangent to the curve of f can be drawn through points C and D. Validate this statement using an appropriate calculation. So if they want a tangent to the curve at f, a tangent to the curve of f at point C and D, you need to find out there's two, not really two. Yeah, there's two. You can calculate the tangent at T, and you can calculate the tangent at C. There's two ways you could do this. I'm gonna assume this question is ambiguous, by the way, but I'm gonna assume that they're talking about the tangent passing through C and then through D. This tangent. I'm gonna assume they're talking about this one. But it's not clear because there could have been a tangent at D also, whichever way it's drawn. However it could be drawn. But I'm going to assume that they're talking about this one. So this is what we're going to do, right? What we're going to do is we're going to see if we find the derivative of the equation. I'll explain it to you now. First of all, the equation is f of x is equal to minus 2x cubed. What was it? Plus 12x squared minus 18x plus 8. I just need to double check that 1 second. Minus 2x cubed plus 12x squared minus 18x plus 8. Okay, right. If we find the derivative to this, right? If I find the derivative to this, it's going to give me minus 6x squared plus 24x minus 18, right? Right. Now, at this point, the gradient is f prime x, because I told you f prime x is always gradient. So the gradient is this, right? To any tangent on the curve. That's the equation for the gradient of any tangent to the curve. So now, if they're saying that the tangent must be through C, now because C and D, really two ways to do this. Okay, wait, give me 1 second to calculate, to think through the teaching aspect of this one. Okay, I figured out this wording, right? So here's the thing. I can't do anything with this question unless I know what C's coordinates is. All right. So I need to first figure out what is C's coordinates, which and C is a turning point. I need to first figure out what that set of coordinates is. And the way I'm going to do that is I'm going to find f prime x. I'm going to make it equal to 0, solve for x. That's going to give me the x coordinate of the turning points. Remember, one of them is going to have to be 1 because we have the set of coordinates of this turning point. So the other one will belong to C. So if I find f prime x and I make it equal to 0, this is going to help me find the coordinates of the turning points and C's coordinates because that's what I need. All right. I'm going to divide right through by -6 just to make my life simpler. So this is -6. This is 0 is equal to x squared minus 4x plus 3. Right. When I factorize this trinomial, it's going to give me x and x. It's going to give me 3 and 1 and a minus and a minus. X is equal to 3 or x is equal to 1. We know that this 1 belongs to A and we know that this 3 belongs to C. So C's x coordinate is 3. I need to figure out what its corresponding y coordinate is. So I'm going to take it and I'm going to sub it back into the original equation to get the corresponding y value. So if I sub back, it's going to give me f of 3 is equal to minus 2 into 3 all cubed plus 12 into 3 squared minus 18 into 3 plus 8. This answer gives me 8, which means C's coordinates is 3 and 8. 3 and 8. Now, a tangent to the curve through point C. If C is a turning point of a cubic function, if C is the turning point, which they told us it is, then the only way a line could be a tangent to a curve at the turning point is if that line is a straight horizontal line, which means it must be in the form y is equal to a number. So how do I know that this would be a straight horizontal line passing through C and D? This is how I know. I know that D's coordinate is 0 and 8 because it's the y-intercept of the graph. And remember the D value at the end is the y-intercept of the graph. So I know that this value is 8. And so if this is 8 and this is 8, that means that there can be a line drawn through the turning point and the y-intercept. And that line is a straight horizontal line because they share the same, they share the same y coordinate. So this line is y is equal to 8. Again, I'm going to say the only way a line can be a tangent to a curve at a turning point is if that line is a straight horizontal line parallel to the x-axis. And how do I know that that line will be a straight horizontal line if the line is passing through both points C and D? It's if they share the same y coordinate. And they do share the same y coordinate. So we can then conclude that the tangent does pass through points C and D. And that's it. Okay, let's look at the next one. Here it says points A, P, and B are joined to form triangle APB. Let's do that. A, P, and B. Okay. Okay, right. Then it says, calculate the area of triangle APB. Right, I know that this is a straight horizontal line. The easiest way for me to do this is to construct a perpendicular, i.e. this line. Because then I can calculate the area by saying a half base times perpendicular height. This is going to be the base. This is going to be the perpendicular height. Now, how do I get the perpendicular height? If I have P's y coordinate, then I'll have this distance. If I have P's y coordinate, then that's the distance from the x-axis to there. That's going to be the perpendicular height. So this is what I'm going to do. I'm going to calculate what P's coordinates is. P is the point of inflection. Remember they told us that in the start, in the information, that P is the point of inflection of the graph. And how do you find point of concavity, i.e. point of inflection, it's f double prime x. So whatever f prime x is, I'm just going to copy from here because I'm lazy. Right. Here's f of x, here's f prime x. Find f double prime x. Right? That gives me a minus 12x plus 24. Make it equal to 0 for the point of inflection. That gives me minus 12x plus 24. Take that over. Divide both sides by 12. Then x is equal to 2. And then to get corresponding y, you take that, sub back into the original, always the original, f of 2 is equal to minus 2 into 2 cubed plus 12 into 2 squared minus 18 into 2 plus 8. That gives me a corresponding y value of 4. So P's coordinates right now is 2 and 4. So I know that this distance is 4. Right? This coordinate, this is 4. Right? And this is 2. Right? So if I know that that distance is 4, I also know what this distance is because it's on a straight horizontal line. If this point is at 1 and this point is at 4, this can only happen on straight horizontal or straight vertical lines, by the way, then I know that this distance from 1 to 4 is 3. So to get the area of triangle AEB, it's a half base times perpendicular height. That gives me a half into 3, which is the base, and the perpendicular height we said is 4, which gives me 6 units squared. That's the area. Okay, that one wasn't too bad. It said for which values of x is f concave down. Concave down is this. This is concave down, right? This point is the x value here is 2, which is calculated it. It's 2. So it's concave down after 2, right? This is concave up before 2. So after 2 is where the solution lies. Follow the arrow. So you say it's concave down where x is greater than 2. Here's the line 2. After 2 is where it's concave down. Okay? And so that's where it's concave down. Okay. All right, 9.5. Write down the values of x for which f is strictly increasing. Increasing the graph, you just look at it from left to right. It's decreasing here, then it's increasing there, then it's decreasing again. Always look at it this way. Right, going this way, you have to look at it for increasing, decreasing. It's increasing from this point to this point, from this x value to this x value, which here, this is 3 and 8. Remember that, right? So it's increasing from this x value to this x value, which is between 1 and 3. 1, smaller number first, bigger number there. X in the middle, always facing the margin as long as the smaller number is on this side. No equals to signs with an increasing or decreasing question ever. Don't put equals to signs. There's a big debate about that, but I don't believe in the equal to sign on increasing and decreasing questions. Okay. Write down the coordinates of the turning points of f of x, h of x, which is f of x minus 3. So the turning points of f of x currently is at 1 and 0 and at 3 and 8. Right? That's of f of x. This is the turning points of f of x. So this is f of x shifted 3 units down, which means the only coordinate that's going to get affected is the y coordinate because it's a vertical movement. It's shifting 3 units down. You're not subtracting 3 from x, you're subtracting 3 from y. This is y. So had you been subtracting from x, it would look like this, f of x minus 3. This is a horizontal movement. This is y minus 3. F of x stands for y, right? So that's a vertical movement. So this is a vertical movement because you're subtracting from y. So if subtracting, you're moving 3 units down, so it's only going to affect the y coordinate. And if you move 3 units down, your set of coordinates is going to be 1 and minus 3, and 3 and 8 minus 3 gives you 5. So those are the two turning points. You move 3 units down. 0, 3 units down is at -3. 8, 3 units down is at 5. It doesn't affect the x coordinate at all. Don't put this in, please. That's scrap work. Okay, and those are your answers there. All right, breather before we get into this one. All right, question 10, the optimization question, right? Okay, it says a metal box without a top is to be constructed from a square metal sheet. So I just threw the square in, right? So we're talking about the blue solid outline. Its sides is 20 centimeters. So this entire distance here is 20 right over, right across, right? So we're at 20 on all four sides. By cutting square pieces of equal size from the corners of the sheet and then folding up the sides, that's how the metal box is formed, right? So they're cutting square pieces from the corners. We don't know what the length of that is. So these square pieces that they're cutting out, we don't know what that length is, so we're going to call it all x. And we know if it's a square, all of them have to be x because all the sides of the square is equal. Okay. Calculate the dimensions of the box for the largest volume. Right. So the word that comes after the minimum or maximum synonym, this is the minimum or maximum synonym, the word largest. The word that comes after that, that's what you need a formula for. So volume, the volume of a rectangular or square-based pyramid is length times breadth times height. So the volume is length times breadth times height. Now, obviously, you can't even start this question if you don't know your volume formulae, right? So the volume of a rectangular prism is length times breadth times height, okay? Can be constructed. Okay, so we need a formula for length times breadth times height. So this is the box that's formed. Here's the box that's formed, right? I need to figure out what this distance is. So very simply, if this distance is x and this distance is x and this whole distance is 20, then this distance must be the full distance minus this minus this. So it must be 20 minus this to give me this part. So this is 20 minus x is minus 2x, which makes this also 20 minus 2x, which makes this also 20 minus 2x, right? Which means the bottom of the box that's formed is a square. And the length of each side of that square is 20 minus 2x. It comes from here, right? Because this distance and this distance is the same. And this distance and this distance is the same. So when you fold the square up, the bottom of the box, this is the bottom of the box, all the sides is 20 minus 2x. Right, so here's the box. The bottom of the box, this is the bottom of the box here. Right, all of those sides is 20 minus 2x. Right, this distance coming up is this distance because this is being folded up. This is being folded upwards, right? And that distance is x. So these distances here that's getting folded up, that's x for all of them. We're talking about these lines. That's the parts that were folded upwards, and that's x. Right, okay. So to get length times breadth times height, we're going to go length times breadth of the bottom shape is that times height of the prism. So it's x times 20 minus 2x times 20 minus 2x. That's length. Hold on, let me just show you that. Length and breadth of the bottom shape times the height of the prism, which is this one. It's always length times breadth times height. Those are the three things when you're forming a rectangular prism. So it's this times that. So when we get the formula, it's x times 20 minus 2x times 20 minus 2x. That's your length times breadth times height. X times 20 minus 2x times 20 minus 2x. This is going to give me a formula for volume. Right? I'm going to get rid of the brackets. This is going to give me 400 minus 40x minus 40x plus 4x squared, which gives me x into 400 minus 80x plus 4x squared. Distribute that in. That gives me 400x minus 80x squared plus 4x cubed. Right. Now, I told you the question says calculate the dimensions of the box with the largest volume. This is your key, right? You needed a formula for volume. Now you deal with this part of minimum and maximum. Now you need to find the derivative and make it equal to 0 and solve for your variable. Now remember, the answer to this is not the actual maximum or minimum. The question says calculate the dimensions of the box with the largest volume. So I need to first calculate the dimensions, which is f, right? We need to calculate that first. So let's first figure out how to calculate the dimensions. You find the derivative, you make it equal to 0. So we're going to find v prime x. It's going to give you 400 minus 160x plus 12x squared. You're going to make it equal to 0, and you're going to solve for x. Right. These, when you factorize, is going to give you, I'm going to divide right through by 4 first, just to simplify my life. That's 100. That is 40. And that's 3x squared. Right. We can rewrite this way. Right. And then we're going to factorize this to give us our dimension. So this is 3x and x and 10 and 10. Minus and minus. X is equal to 10 over 3, or x is equal to 10. Now, keep in mind, right? There's two ways to actually do this. At this point, we don't know what the largest volume is. Is the largest volume going to come from this value, or is it going to come from this value? Now, it's very simple to actually figure that out if you think of it in terms of a graph. Now, here's the thing. There's two ways to think about this. You can think of it in terms of a graph, or you can resort to what I taught you in the start of the year, where you sub back in, right? So either you're going to sub this 10 over 3 back into the original equation and get a corresponding volume, and take this 10, sub back into the original and get a corresponding volume and see which one is the biggest. Or you can think of it in terms of whatever this graph is, the original graph, whatever that is, it's a cubic function. And you can see where the minimum or maximum is. So there's two ways to do it. You can sub back in, or you can think of it in terms of a graph. I'm going to sub back in for now. I'm going to go v of 10 over 3 is equal to 400 into 10 over 3 minus 80 into 10 over 3 all squared plus 4 into 10 over 3 all cubed. Then I'm going to get an answer here. And then I'm going to do the same thing for the 10. So 400 into 10 minus 80 into 10 squared plus 4 into 10 cubed. And then I'm going to get an answer here. All right. I don't know what either of these answers are. Give me 1 second to punch it in. Okay, so here's the solutions for the two. When you sub 10 over 3 back into the original, it gives us this for the volume. And when you sub 10 back into the original, it gives us this for the volume. So which one will produce the largest volume? Obviously, it will be the 10 over 3. So therefore, x must give me 10 over 3. And we need the other dimension as well, which was this one. So the x value must be 10 over 3. The other dimension value is 20 minus 2 into 10 over 3, which gives me 40 over 3. So the dimensions has to be 10 over 3 and 40 over 3. All right? So meaning to say you can't take x as the 10 value, this one, and sub it back into this 20 minus 2 into 10 to give you that corresponding dimension, because that's not the dimension that will produce the largest volume. This is the dimension x value that will produce the largest volume. So this is the answer to it. So your answer must give you this 10 over 3 and this 40 over 3 as your final answers, these two. But now there is the scenario where the memo doesn't give you, you see, they can't take out the solutions for this. They can't take out the marks for these solutions that we just put on the board. But there's 2 marks that they actually want to see. They want to see you look at it in terms of a graph. That's what they want. They want you to use your cubic function theory. So at this point, they don't want you to sub back in, although they have to give you the marks for that. They don't have a choice. But how the memo gives it is they want you to think of this at this point in terms of the cubic function. So this graph here, which is the original formula for the volume, that's a cubic function graph. And the cubic function graph, when you find the derivative and make it equal to 0 and solve for x, is you calculating the turning points of that cubic function, which means that the cubic function should look like this. So this is the volume formula, the cubic function formula. It's 4x cubed minus 80x squared plus 400x. I'm just putting it in proper order, right? And so the graph should look like this, where the x values of the turning points is 10 over 3 and 10, right? And so now, does the graph go up or down first if the a value is positive? The graph is going to go up first, right? So it's going to go up, then it's going to come down, then it's going to go up. So the largest or the maximum of this graph is here at 10 over 3. So they want you to get this 10 over 3, but they want you to get it with the point of concavity, which means they want you to calculate the point of concavity first to see which one is concave up, because concave up will produce a minimum, and which one is concave down, because concave down will produce a maximum. So this produces a maximum for concave down, and this produces a minimum at concave up. So this is your maximum, and this is concave up produces a minimum, right? How do I know that the graph has to go this way and not this way? It's because of this value, right? The graph must go up first, then come down, then go up, right? Okay, but besides that, they want you to use the point of concavity to determine where it's concave up and concave down. So the point of concavity is v double prime x. So if you find the derivative again, it's going to give you minus 160 plus 24x. All right, then you make it equal to 0. And you solve the x. That gives me 160 is equal to 24x. Divide both sides by 24, sorry. 24, then x is equal to, no idea what that is. Give me a second, I will figure it out. $160 divided by 24 gives me 20 over 3. So this point is at 20 over 3. And before that, the 10 over 3 lies, and 10 over 3 lies in concave down, and the 10 lies in concave up. So that means that the 10 over 3 will produce the maximum volume, and the 10 will produce the minimum volume. Okay, they just want you to show that part also, apparently. But anyways, that was that. You can do it the first way if you'd like. You can do it the second way if you like. I saw them giving marks for this way. I can't lie. I didn't see the other way. But I'm pretty sure that they cannot take out the marks if you thought it through properly. And if you subbed back and you gave them the solution of 10 over 3 and 40 over 3 for the dimensions. Okay. And then the last question is this probability. It says a six-sided die is rolled and the number of dots landing face up is noted. Consider the following events. Event A is the number observed is 2 at the most. Event B is the number that landed face up is an even number. Event C is the number 6 is facing up. Use the given information to determine separately the probability of event A and event B. So the probability of event A, the number observed is 2 at the most. So 2 at most, meaning, remember the word at most in probability means 2 or less. If they said 2 at the least, it would mean 2 or more. So 2 at most, meaning the two numbers that could have landed face up for the event A is the numbers 1 and 2. That's the 2 or less, right? So the probability of event A is 2 options out of 6, which gives you a 1 over 3. These two options are the number 1 and 2, right? Because event A was the number observed is 2 on the dice, the number 2 at most. So 2 or less. Okay, and then event B, the number that landed face up is an even number. That gives me 3 options out of 6, which gives me 1 over 2. 3 options because there's 3 even numbers on a dice over total possible 6 outcomes. Okay, next question says you use the probability of A and determine the complement of A. The probability of the complement of A is equal to 1 minus the probability that something is A. That gives me 1 minus the probability of A was 1 over 3, which gives me an answer of 2 over 3. All right, next question says, are the events mutually exclusive? Meaning all 3 events. Are they mutually exclusive? Give a reason for your answer. So the event A is 1 and 2. Those are the 2 things that can occur in event A. In event B is all the even numbers. So it's 2, 4, and 6. Oh my. And event C is the number 6. So are the events mutually exclusive? Mutually exclusive means there must be nothing in one that's also in the other 2. So they must have everything that's completely different in all 3 events. So you'll say no, the events are not mutually exclusive because the probability of A, B, and C is not equal to 0. Right? The probability of all of them is not equal to 0 because there's things that they share in common. So for mutually exclusive events, they must share nothing in common, right? The 3 events. So they're not mutually exclusive. Okay, next. Calculate the probability of A or C. The probability of A or C, this comes from our addition rule formula. The probability of A or C is equal to the probability of A plus the probability of C minus the probability of A and C. Right. So the probability of A and C, if we're looking at A, A's events is 1 and 2. And C's events is 6. Right? That's what we got. A is 1 and 2. C is 6. Right. A and C are mutually exclusive because there's nothing that they share in common. And remember, if these 2 events are mutually exclusive, then the probability of A and C must be equal to 0, meaning there's nothing that they have in common. Probability of A and C, not the probability of A or C. So this is what I'm trying to calculate. Right? The probability of A we already calculated in a previous question. It's 1 over 3. The probability of C we calculated, oh, we didn't. It's 1 over 3 anyways, because the probability of C is just 1 outcome out of a total possible 6, so it's 1 over 6. And then you're going to punch that in on the calculator to get the probability of A or C, which gives me a half. And that's that one. All right. 11.1.5 are B and C independent events. Again, I'm going to pull B's events. B is 2, 4, and 6. Its probability was a half. And then C's event was just 6, and its probability was 1/6. Right? This is 3/6. This was 1/6. Okay. And 3/6 is a half, remember that, right? So that's the probability of B and C. It says, are B and C independent events? To prove independent events, you have to have probability of B and C must be equal to the probability of B times the probability of C, right? If you don't know this work, you need to go back to the grade 11 videos and you need to watch those videos on independent events. Okay, probability of B and C. What do they share in common? They share one element in common. So the probability of B and C is 1/6. Right? They share one event that's common. So the probability of B and C is 1/6. The probability of B is 1/2, and the probability of C is 1/6. So we have 1/6 is equal to 1/12. That's obviously not true. So you say, therefore, the events B and C are not independent. Because remember, for them to be independent, this side must be equal to that side. And this is the formula that you use whenever you see the words independent events. So you say the events are not independent because the left-hand side is not equal to the right-hand side. Okay. And then the last question here. The probability of getting the first answer in a quiz correct is 0.6. If the first answer is correct, the probability of getting the next answer correct rises to 0.7. However, if the first answer is incorrect, the probability of getting the next answer correct is 0.4. Okay, so let's deal with the first scenario, all right? You can either get it correct or it can be not correct. So this is the first answer. The probability of getting the first answer in a quiz correct is 0.6, which means this has to be 0.4. If the first answer is correct, meaning from here, build another branch, right? The next answer, the probability of getting the next answer correct is 0.7. So this will be 0.3. So if the first answer is correct, the probability of getting the next answer correct, this whole thing is the next answer. The next answer correct would be 0.7, and the probability of getting the next answer not correct would be 0.3 if the first answer was correct. And then it says, however, if the first answer is incorrect, let's change that to an I. Right? If the first answer is incorrect, the probability of getting the next answer correct is 0.4, which makes this 0.6 for getting the next answer incorrect if the first answer was incorrect. And then we have our options. Either you can get both correct, you can get the first one correct and the second one incorrect, the first one incorrect, the second one correct, and both incorrect. Right? Those are the scenarios. With the use of a tree diagram, that's the tree diagram, determine the probability of getting the second answer correct. The second answer correct is this option. Oopsies. This option. That's the second answer. Oh, correct. Sorry. This is us getting the second answer correct. And this is us getting the second answer correct. Determine the probability of getting the second answer correct. So to get this probability, it is 0.6 times 0.7. 0.6 times 0.7. And to get this one, it's 0.4 times 0.4. So multiply across the branches, add down to get your answer. So your answer here would be 0.6 times 0.7 plus 0.4 times 0.4, which gives us an answer of, I have no idea, 1 second, 0.58. And that's the final answer there. This question was removed from the paper, and that was 2025 preparatory examination paper 1.